Good morning to all of you. Thanks for participating in the webinar about the real cost of energy storage. I hope you can hear me. It would be great if you can write into the chat if all is okay with understanding, and then we will start with our presentation. Great, so it seems all to work. So then let us start. First of all, I would like to introduce myself. My name is Bridget. I'm working with BlueSky Energy, and I'm responsible for sales and marketing there. So then let's get to some general information about the webinar. So the list of attendees is hidden and is visible for us as the owner of the webinar. If you have questions, we do not hear you if you talk in your micro, so please write that in the chat button. You can see that on the right hand side below of the video camera, below my picture, and here you can type in your questions. I will do the presentation, and at the end of the presentation I will come to your questions and will answer them afterwards. So all of them will be answered, and you will receive your information as requested. Yeah, of course, we would like to improve ourselves. So after the webinar you will get from EduDeep an email to give some feedback. And we very much appreciate you giving feedback and telling us how to improve and what you liked. So then let's start with the today's topic. And this is the real costs of batteries, of electric energy storage, and how to calculate that, and what is the return on investment of that. So first of all, what we would like to talk today is the cost of energy storage, how to calculate them, then the financial returns on batteries, then a tool to make an amortisation calculation. Then we introduce our energy management system to you, and give some short information why it's increasing the value of battery storage. And in final conclusion, we give you some options, some food of thought to think about possible options, how you can also go on the market with batteries as leasing and contracting options. So let's start with point 1, the cost of energy storage. So the most common way to calculate how much is a battery is to take the costs and to divide that through the kilowatt hours of capacity. And the output says then more or less how much the energy storage is. What we have to think about is, did we add all costs, all investment costs? It's one thing to check the battery and divide it to the kilowatt hours of storage of capacity, but also to check about installation costs, about the inverters needed, about some technical options. For example, if you install a lithium battery, do you need some building restrictions to follow, or some other parts to be sure of to have that all safe? The way I describe now is a simple and easy way of calculating, but sometimes it's oversimplifying and it doesn't give you the real costs, and this is now the topic of today's webinar, to check if the outcome, or what about the real costs of battery storage. First, we will come back, sorry for that, to our example of before. If we do the simple way of calculating the battery storage, we, for example, have 10 kilowatt hours of battery capacity with a price of 3,740 euro. And in that case, we divide that, and we have an outcome of 374 euro per kilowatt hour as an invest. So regarding this calculation, we would say the battery, or the invest per kilowatt hour for the battery, is 374 euro. So coming now to the point of the true costs of energy storage. This is a benchmark which takes into account the energy throughput. The energy throughput is important to know how many kilowatt hours in total will pass through the battery till the end of life. So what is possible with the battery of capacity during lifetime? And that brings us here to the number of cycles. So it's important to know how many cycles can the battery do, which depth of discharge does the battery offer, and the round trip efficiency. And the result in taking into account those through parameters of cycles, of DOD, and of round trip efficiency brings you to the result of the energy throughput and gets us down to the costs of usable kilowatt hours for the battery. So to make that a little bit clearer, in our example we have a battery storage with 10 kilowatt hours of total capacity at 3,740 euro. Its depth of discharge is 80%, and at those 80% we have 5,000 cycles. The round trip efficiency lies at 85%. So in order to calculate the energy throughput, we take the 10 kilowatt hours, then take it per 0.8, which is the 80% DOD, per 5,000 cycles, per 0.85, which is the round trip efficiency, and then we come to the energy throughput of 34,000 kilowatt hours in total. So coming from there, we are doing now the calculation about the costs per kilowatt hours. So at the 3,740 euro per 10 kilowatt battery, we have 34,000 kilowatt hours of energy throughput. So we do the calculation, which you see here, for the total investment of 3,740 euro, and then divide that through the 34,000 kilowatt hours of energy throughput, which brings us then to effective costs of 0.11 euro per kilowatt hour calculated by the throughput. So the best benchmark to calculate battery costs is to compare them on the energy throughput and to let influence the decision makers, as told before, and which I show you now in the next sheets. So we did a comparison ourselves, which you can also see on our website in the blogs. And there we had a Greenrock saltwater battery at 0.11 kilowatt hours. We took a lithium battery, which is at 0.12 euro per kilowatt hour. We had two lead acid products to compare, and this is at 0.14 and at 0.70 euro per kilowatt hours. And then here you see a lithium battery given with 1,800 cycles. You think that might be a little bit low, But this is a point what people are giving or what companies are giving in warranties. So this brings us now to our next step. So what else is to be respected? The costs of energy storage are influenced by cycles. So in that case, it is not only important to check the cycles giving in some marketing issues, but also to check if the warranty backs up with the cycles given. And this is what I mentioned before. So the product we had there in our comparison offered in the marketing sheets lots of more cycles, and in the warranty it placed only 1,800 cycles. So what is the need of it if afterwards the warranty is not valued anymore? And this is also a point to check and to think about. So the costs of energy, they are influenced by the storage capacity and the round-trip efficiency. And those two positions are also influenced by temperature. So for you to know, it's important or to check what is the perfect temperature range and how much efficiency does the battery offer in that case. And this is also something to look in the data sheets of different battery types to check in which operating frame the efficiency of how many which percentage is given for you. Yeah, and this comes then to the final point, to see how the cycles and the depth of discharge correlate. For example, you have batteries given that they can discharge 100%, but if they do so, they offer lower cycles. So this is also to check if a battery is offering 10,000 cycles, so what is the depth of discharge in that case? Because most times this is really a reduced amount of depth of discharge. So to calculate in all those facts makes it a little bit difficult, but in the end it makes the outcome more informative for you. So if you do calculating the real cost of battery storage, we recommend to go along with the energy throughput, and ahead of that check also into the details of the battery and see what is there offered in warranties, what is offered in temperature range, and in dependence of depth of discharge and cycles. So we come now here to an example about how energy storage benefits or helps you to gain money. And this is a photovoltaic example I would like to speak about. And the example or the general situation at photovoltaic is during sunshine hours. People normally are not at home, so we have lots of energy production and only low consumption of general consumption, because the high demand is during early morning and evening hours. So the battery storage adds the value by shifting the excess, your PV's excess, from the midday hours to the morning and evening hours. So that you will see here in our example, the yellow ones are the sunshine hours, where we have the excess hours of the PV production, and here in front of that, in the morning hours and in the evening hours, we have those peaks of consumption due to the inhabitants coming home or standing up in the morning and doing their cooking and whatever. So this is what the battery tends to do, to shift this overproduction that you can use your energy during the evening and morning hours. And you will currently use your own energy and not another imported one from the grid. So, first of all, if you think about energy storage, if you think about batteries, it's important to find the economic value of the battery. So, how much surplus energy are you feeding back into the grid? And how much, in comparison to that, do you get for your feedback tariffs? And in comparison, how much is buying the power from the grid for the evening hours? So we have here an example. We have a customer paying 15 cents per kilowatt hour for its power delivered from the grid, from the mains grid. And for his surplus PV production feeding back into the grid is 0.03 euro per kilowatt hours. So the difference is 12 cents per kilowatt hour, and this would be the financial return generated by the battery storage. If you don't have to pay those 12 cents extra in the evening for your own energy, which you produce during day hours. So, one point is the calculation we did before to save money and use your own PV or solar energy. But there is also the financial benefit of battery storage if you have a grid failure and you need a backup. So, for example, a producing company, a company with 15 people working there, and they are facing a grid failure for 1 hour, which doesn't seem too much, and which is happening with heavy storms or bad weather all over Europe. So we do assume that there are 15 people working, and they do earn 60 euro per person an hour. Oops, sorry, to come back here. And if we have only 1 hour of energy failure, we do have 15 people for 1 hour with 60 euros to wait for not working anyway, and that would mean 900 euro, which you are missing in that case, in this example. So having a battery storage would bridge those occasional failures, and you can keep on working and your staff will do the same. So this is another way of seeing the importance of battery energy storage. There is another benefit of the emergency backup and the functionality of itself. If there is a sudden grid failure, you know that some electric devices, they do not handle the loss of energy, the immediate loss of energy quite well. So in that case, if that's happening, data can be damaged, or also the device itself, the machine, the whatever electric device can be damaged. And this regarding to a Swiss study is 10 euro per kilowatt hour, which is emerging costs if this grid failure is happening, and yeah, you are facing those shutdowns of your appliances. So, as already shown in our table of content, we are coming now to the amortization calculation. For BlueSky Energy partners, we are offering a special Excel-based calculation tool which helps to make it visible how the battery storage is working. So it's important before setting the initial invest to know, especially for companies, for business solutions, how the annual financial gains are and what is the profit of installing the battery storage. And how long in years does it take to reach break-even with this investment? So if you are a BlueSky Energy's partner, please come back to us and we will share the tool with you and also help you with the first calculations there. I will now show you in the next sheets how that looks like. So in the background, you can enter then the relevant data, such as costs of investment, such as energy prices, how much is the grid price, and so on. And then, depending on those entered data, you will see the break-even in years. And in that calculation we had here, it is shortly at 14 years. So this makes it even easier for you to see at which point the investment, the size of the investment you are planning, will make sense and is reaching break-even. Another statistics you will see there is the blue bars are showing the energy price now, so in the first year, and the assumed increase in the following years. And the yellow bars are showing the costs per kilowatt hour regarding battery storage, regarding inverters, regarding PV and energy management system. And what you clearly can see here, that those prices are being stable because you do the invest in the first year and then you are paying that back. In the other contrary, we do see from the previous years that the energy prices are increasing constantly, and in that case it makes sense to install battery storage earlier and not waiting until the energy prices are even coming up higher. So to summarize the amortization and the calculation of the saltwater batteries, so it is mainly important for industrial and commercial applications to know about the value, to know about the return on investment, and to know about the financial situation. So in that case, it helps the customer, it helps you as a partner to get a clear financial picture and then to start the project with it. So do the planning ahead of it and then you know where you're going into. So coming now to the next topic of today's agenda is the energy management system, the EMS. An energy management system we do offer also a standalone solution. So either if you have a client who is not ready to go ahead for a battery right now, it makes sense to think about energy management system. People having a PV installation do have the excess energy during the day hours, as we have seen before. So in that case, if the energy cannot be used during those midday and afternoon hours, it makes sense to shift the energy from those hours to make it feasible. So an energy management is a low initial investment. It is optimizing your photovoltaic, your PV installation, and this is done by using excess PV energy to shift loads. For example, you can switch on, or the system will automatically switch on the washing machine if enough excess power is available. Then it is possible to use excess PV energy for functions like power to heat. So your hot water boiler, your heating element will charge up and will heat, for example, boiler temperature up to 90 degrees instead of the usual 60 degrees. And so the excess energy will be used and the energy will be stored for later evening uses. Or, of course, using the excess PV energy for your e-car charging. So to make that visible again in our draft is here to see those peaks we have on excess energy during midday and afternoon hours and the peaks of use to make that work together, and this is shown here. So for example, if we see here the washing machine, normally people are switching on the washing machine when leaving home in the morning, and then you have in the early hours a peak which is fed through the grid. In that case, the EMS helps you to shift this action, and the washing machine will, with help of wireless sockets, be switched on as soon as there is enough excess PV energy, and then the washing machine is running exactly in this period of time. The same would be here with the dishwasher. Instead of switching it on in the evening hours before you go to bed, the dishwasher is starting with wireless sockets during the excess hours of PV energy. The battery storage will also take up the energy during those hours, so you afterwards have in the evening hours your backup from the battery storage. And the same would be with the e-car charger, with e-mobility. If you charge your e-car during the day hours and your EMS handles that, your energy management helps you in that case, then you can decrease those peaks here shown in the evening. Yeah, this is now the overview of the energy management system. It's a low initial invest. You can anyway upgrade the system later with the battery system. You can upgrade it later with other functions, and you can immediately increase your PV energy self-consumption up to 30%. And the average amortization period is 4 years for an energy management system. So to our last bigger topic today is the different options of business models. So of course we talked now about buying batteries, but there might also be possibilities of other business models. For example, a leasing model. Leasing means that the client becomes the owner. As you know that for with car leasing, you pay the monthly rates, and after finishing the monthly rates, you are the owner of the car, or in our case, you would be the owner of the battery. The client is responsible for operating the battery storage. The client is responsible to maintenance for the surroundings and so on. That would be the possibilities of leasing. Then we have another option to think about, and this is contracting. Contracting means that the vendor is still the owner of the battery, of the storage system, and the client gets a contract and is entitled to a certain amount of kilowatt hours of storage capacity. The client is also responsible for the setup of the battery, so the place where it is, the temperature, the surroundings there. So this is all working. And in contrary, the vendor is responsible for a working battery. Ahead of that, there is another possibility, and this is performance contracting. Performance contracting, in that case, there is the vendor, the operator, and the owner of the installation. And what is done in that case is that the current situation is evaluated at the client. So where do you have potentials for saving energy? Which applications have to be followed to make your energy consumption to make that better? So the savings potential is analyzed, and agreed on that analyze, there is a percentage of savings. So in the contract it is then agreed, okay, with those and those measurements, the client will get a certain percentage of savings as a benefit. And all further gains coming out from the installation, they will come back to the owner. They flow back directly to the owner, to the vendor and operator, as we have it here. Yeah. For the end of the presentation, we just would like to show you some statistics about energy costs in Europe. You see here that we have absolutely different costs, with Denmark at the highest, and Great Britain and France at the lowest grades. And yeah, this is something what we referred to, we have to check in our calculations as well, to see where we lay with our investment and our return on investment. So in Austria we had increases of an average of 8% per year in the last 20 years. This is statistics where you see especially the taxes increased at 140%. The energy price itself did not do that much, but in total we had 160% of increase, which gives the average of 8%. So, and if we go ahead with that, Germany is a little bit lesser in increase, but still in the last 17 years we had 6.5% of increase in the energy costs. And experts do see that a constant increase per 3.5% per year seem realistic. So in that case, assuming the increases also at 3.5%, we do have changes in the next years, and that even makes a battery storage more interesting for your further calculations. So then, to summarize our today's webinar, we had first of all our point of calculating the real costs of energy storage, which was that we intend to go for the energy throughput. If you know the total energy throughput in kilowatt hours for your battery during lifetime, then it makes it easy to compare different batteries and the costs of it. The second point was the Excel tool for doing the amortization calculation. So we will assist you in that. We will offer to all partners of ours our Excel tool, and then it is easy to make the calculations and to see the break-even for investments of battery storages, especially then for business installations, where it is important to know ahead of time when we will reach break-even with the investment. Then the Greenrock Energy Management optimizes your self-consumption, also without battery storage. It helps you in advance to shift your loads and to optimize your PV energy, for example, your PV consumption, and this is possible up to 30%. And the last point was the food of thought about different business models. So just be creative. You know the market where you are located best, and if there is anything, an option to speak to a client, make another offer, and go ahead maybe with a leasing, with a contracting option. And if there are some bigger projects to speak of, just come to us, and we will check that out if and how we can assist you in these business models. So far, this is today's presentation, today's webinar of the real costs of battery storage. Are there some questions from your side? Then please add them on the chat. So there is one question that we talked about the price of batteries. And the person is asking for the inverters. What about these costs? So this is something, if we come back, we talked about batteries because this is the normal way that you have one battery to compare to the other. If we go back to the sheets, just a minute. So here we are. So we do offer as Greenrock, as you know, also our home and business all over solutions. So this is absolutely plug and play pre-installed Greenrock systems. And in those systems there is the battery, the inverter, the energy management, the installation, all prepared already. And that would mean then here, this point, just take the complete costs of it and do the same calculation. And if you compare it to other batteries, then make sure that then you have also calculated the extra costs of inverter, of installation, of additional building restrictions, whatever, to add all those costs up and do then the calculation as we did before regarding the energy throughput and regarding the costs per kilowatt hour in respect to the energy throughput. I hope that helps to answer your question. So it seems that there is there is another question. So for how long time do you have a track record on the annual decline? I assume this question is referring to the decrease of capacity in the battery, and this is something we can share in our afterwards. Yeah, okay, right. It's here the question is regarding the decline in capacity, and we can share then statistics with you afterwards where you see the gradual decline of the battery during the years. So we can say after 5,000 cycles there are still 70% of remaining capacity at Greenrock saltwater batteries, and the decline is constant. So it is constant then going down, and you can still use the battery also with even 50% of capacity. Does the amortization tool also include cost for inverter changes during lifetime? This is something we have to check up. I did the calculations myself. I did not enter those inverter changes during lifetime, but I'm sure there is a possibility to add that in, and then we can see that as well. So of course this is something which is easy handleable, and we can add up if it's not yet done. For my case study it was not necessary, but we'll have a double check on that. So far I think we are done. For all to you, thanks a lot for checking in, for joining in. As usually we will share the presentation with you afterwards. As promised, I will share the statistics about the decline of capacity with you, and we will also share a link of the video clip of the presentation of today. So all this information will be sent to you in the afterwork with email. And yeah, thanks for joining in, and see you next time. Have a nice day. Bye.